Hello everyone, my name is Finding Pepper and welcome to episode 4 of the Dungeon Crawler tutorial series. This episode will be coding enemies into our Dungeon Crawler. I'm going to make two types of enemies, a slime and a spider, and we will be able to place them in the editor, and then we'll also cover how to add them to our room save codes. Let's get started. Alright, so we need some assets, so I'll go over to my YouTube tutorial assets project and take the DC4 sprite and put it in my backpack. Then head back over to my project, open up the backpack, and drag out the sprite. And we see we have a whole bunch of cool costumes. I'm not quite sure yet how I'm going to divide up this video, so we might not use all of these costumes, or I might change the sprite in the YouTube tutorial assets. We're going to need a new sprite for our enemies, so we will make a new sprite and call it enemy, or actually let's call it entity because it might not always represent enemies. Now I'm going to drag all my slime costumes into the entity sprite. Great. Let's delete costume 1 here, and we should have a total of 16 costumes. I'll hide the entity sprite. Now we need a way to place down our enemies, so I'll drag the first green slime costume into the tile sprite. Now I'm going to make two new lists called entity index for all sprites and entity type for all sprites. Okay, these lists will hold where we place our enemies in the editor, so rather the spawn points. Now I'm going to separate off our editing script with a block called edit tile, run without screen refresh, and I will plop it here in stamped tiles inside the editor is greater than 0, and what was there instead we will go inside the block. Now we need to add our slime tile to our tile key map list. So I'll add a new item and I'll put a 9 here. I'm going to use 9 for the entities. You can use whatever you want, of course. I'll also add a when 9 key pressed, next brush 9. So we can access this brush. Now in edit tile within the if mouse down, I'm going to check with an if else if item brush of tile key map equals 9. This is checking if we are placing down an entity. That means that all entities will need to be key 9 in tile key map and nothing else. I'll put what's in mouse down already in the else condition. Now I'd only want to place our entity when we first click our mouse, but there isn't a very good way of testing that, so I'm going to go into main, create a new variable mouse for this sprite only. Now when I receive check controls, I'll check if mouse down, and if it is, I'll change mouse by 1, and otherwise I'll set mouse to 0. So this way we can check if mouse equals 1, then it's the first frame that we press our mouse, because this is a change here, not a set. So then in tiles, check if, and then we need an of block because it's in the main sprite. If mouse of main equals 1, then with an if else, we want to remove the enemy if there's already an enemy there. So if entity index contains tile index, then we will delete the items in the entity type. So delete item number of tile index in entity index of entity index. And then we'll do this again. The first one will be entity type, and then the second one will be entity index. So we need to delete in both lists. Now, if there isn't already an entity there, then we need to add an entity. So we'll add brush, so the number of our costume, to entity type, and then we'll add tile index to entity index. I also want it to display an entity if there is one at a given tile. So in stamp tiles, I'll check if entity index contains tile index right after if editor is greater than 0. Tile. Actually, we're going to do this inside the if editor is greater than 0, because we only want to display the entity when we're in the editor. Great. So if this is true, set ghost effect to 0, and we'll switch costume to item number of tile index in entity index of entity type. So we find the entity's type, and then we stamp. Let's run this and open up the editor and try placing a slime down. There we go. Great. Now when we exit the editor, they disappear. That is good. Okay, now in entity, going to have two messages to control entities appearing and disappearing. One will be called clear entities, create new message. Then one will be spawn entities. When I receive clear entities, I will delete this clone. When I receive spawn entities, then I'll make a custom called spawn entities. And this will loop through the entity index and type lists. So I'll make a variable I to hold our position in the list, set I to 1, then we will repeat length of entity index. Each time we will change I by 1, then make a new variable spawn index for this sprite only, set spawn index to item I of entity index. Then we'll make a new block called spawn entity, and then an input type. Run without screen refresh. And we'll do that here, spawn entity item I of entity type. Now I should take a moment to point out this is essentially Griffpatch's code from the tile scrolling platformer, which is a pretty cool tutorial, I'd recommend watching that or checking out some of Griffpatch's other tutorials if you haven't already. Now in spawn entity, let's check if type equals the type of our slime. Let's see in the tile sprite the costume is number 34. So if type equals 34, we'll make a new block, clone entity of type, then an input type, then run without screen refresh. Now I'll clone entity of type green slime. Now let's make some new variables. Speed X for this sprite only, speed Y for this sprite only, type, tile index. Now we're going to set type to our type variable, and we'll set speed X and speed Y both to 0. We're not going to use those quite yet. Then we set tile index to spawn index. We'll set our size based on the tile size. So that'd be tile size divided by 16 times 100. Remember, our tile images are 16 by 16, so that's why we divide our tile size by 16, and then we multiply by 100 to get it into a percent. Now we'll set our position based on our tile index. So now this is a bit complicated, I'll do tile index, and then we divide it by our grid height and take the ceiling, and this will give us our Y level, because if you think about it, the tile index increases by grid height when you move up in the grid. Now the center of the screen is 0 in our standard XY coordinates, but in our tile coordinates the bottom left is 0, 0. So we need to subtract from this half of our grid height. So grid height divided by 2. I'm sorry, this should be grid width. And tile index divided by grid width, because each row has grid width things horizontally, so if we move right by grid width, then we will loop around to the next row and then be at the tile above us. Now this will have our tiles being centered incorrectly. We want 0, 0 to be an intersection of tiles, but with this method, it will be the center of a tile. So we need to subtract half a tile. And then finally, we multiply the whole thing by the size of our tiles to get our final Y position. Now for the X, we set X, then I'm going to duplicate this, and then we'll replace the ceiling if divided by with a modulo, because the X loops with the grid width. So say we have a grid width of 10, then the X coordinate of tile 1 would be the same as the X coordinate of tile 11 would be the same as the X coordinate of tile 21. So that's why we use modulo. Modulo is remainder. This will get us a number between 0 and 9. We want a number between 1 and 10. This will also loop a bit incorrectly because the bottom left is 1 and this would treat it as 0. So we need to subtract 1 from the tile index and then add it back after we modulo. Now we'll put it here, and now because this is the X direction, we subtract grid width divided by 2 rather than grid height divided by 2. Finally, we can create a clone of myself, and then we'll set our type back to the empty value. I'm going to use the type of empty value to represent the main entity sprite, because it will not be a clone. We should also set that when the flag is clicked, so when flag clicked, set type to the empty value. Before I do any behaviors, I'm just going to write some code to display our entities so we can see that things are working. So when I receive, and then we'll make a new message called display entities, create new message. Now we'll only want to display them if they have a type greater than the empty value. So if the type is equal to the empty string, it should not display, but everything else is greater than the empty string, so it will display. We hide, but it's okay because we then stamp. So again, we're using the pen. Now we need to use our spawn and clear and display blocks. I'll start with display. Right before display player, we'll broadcast display entities. Then in save, when I receive load room, at the top we'll broadcast clear entities. And then before we broadcast done loading room, we'll broadcast spawn entities and wait. And then same down here at the very bottom before done loading. Now in tiles, when we enter the editor, in addition to saving room, we will also afterwards broadcast clear entities and then spawn entities again. It's very important that we broadcast clear entities before we spawn our entities. If we don't clear all the existing entities, then not only will we have more entities than we should, so more clones, but every existing clone will create a clone of every new enemy. So the amount of enemies will grow exponentially. And I'm going to broadcast clear entities with a wait just to make sure we finish that before we spawn the new entities. And same in load room. This should be broadcast and wait. Alright, now we don't want the entities to be around when we're in the editor, so I'm going to get when I receive done loading room, if editor is greater than 0, then we'll broadcast clear entities. Run that. Now we should see our two slimes appear even when we're not in the editor. I should be able to remove them and place them down. Now let's code up some behavior for our slimes. I'm going to make a new broadcast, which I will broadcast in our main sprite called move entity. We'll create that new message, and then in entity, when I receive move entity, I'll make a custom block called move entity, run without screen refresh, put it there. First of all, if type equals empty, then we'll hide and stop the script. Otherwise, if type equals green slime, then we'll make a custom block called tick slime. Run without screen refresh, and we'll put it here. Now this will hold our behaviors for our slime. Now our slime needs collisions, and so do our other entities, so I'm going to go into the player sprite and grab our collision scripts. Going to start with getTileAt, drag that into entity. Then I'll drag our handle X collisions and handle Y collisions, move X and move Y custom blocks. Okay, now here they all are stacked on top of each other. Just going to separate these out. Now I'm going to modify our move X and Y blocks. We're not going to change speed X by our keys, of course. We won't do this set speed X either. We'll just leave the repeat loop here. We can also remove our if editor is less than 1. We can do the similar thing for move Y. Delete this top part and remove the editor is less than 1. Okay. Now back in tick slime. I want our slime to walk towards our player. So I'm going to point towards player. But I don't want the slime to actually rotate, so I'll set rotation style, don't rotate. Now I'm going to make a block called move forward. Add an input speed for the run without screen refresh. Now I'll use it here, move forwards, and I'll give it 2 as an input. Okay, so I will set speed X, and then I'm going to use the move steps formula because we're moving in the direction we're facing. So we set speed X to sine of direction times speed, and we'll set speed Y to cosine of direction times speed. Move X and move Y. I'm gonna run this, and our slimes should move towards us. And there's also not much acceleration, they just move at a constant rate. So I'm going to add an input to this called damping, and I'm going to set damping to 2 as well. Now rather than a set, I'm going to change speed X by this amount, and then I'll subtract speed X from it. So this is the difference between our target and our current, and we're changing our speed X by that. So this is exactly the same as what it was before, but now we can divide it by damping. We won't get to our target speed all at once, we'll get it in a little while. We can do the same thing for our speed Y, changing the set to a change, and then subtracting speed Y, the whole thing divided by damping. So now the slimes are a little bit smoother in their movement. However, they still all bunch up in one place. So I'm going to set the damping to pick random to a random amount from 1 to 3. So I'm going to run this. Now they get kind of bunched up, but they stay separate a bit. Let's also make sure that they can collide. Aha, they can collide, but remember we have not set their width variables. I'm going to add that to my clone entity of type. I'll add text input width, then a number input width, then a text input height, then a number input height. And I'll set the width and height of our slime to 14 for the width and 6 for the height. Remember that these numbers are half the actual height of the enemy. So now in clone entity of type, in addition to setting type, we'll also set width to width and height to height. So now we should see that they collide with the walls better. Now let's give our slime some animation. I'll go to tick slime. So we need a variable to keep track of the slime's animation frame. I'll call it frame. This is similar to what we did for the player. At the beginning of tick slime, I'll change frame by 0.5. We should set our frame to 0 in our clone entity. Okay, so in tick slime we can switch costume to join, green slime walk. Then we'll use mod floor frame, and then we'll mod by the amount of frames we have, which is 6. Then we need to add 1 to it because, again, this gives us a number from 0 to 5. We want a number from 1 to 6. Because we're changing frame by 0.5, that means that each animation frame will last for 2 game frames. Great, and we're using the join block, so we're switching costume based on the costume name. Now the slimes have an animation. That's fun. Alright, now there's also an idle animation, which I feel we should use. Because these slimes shouldn't be following us from all the way across the room. We should have a radius around the slime in which the slime becomes angered at the player. So I'm going to make a new variable called angered to keep track of whether the slime is angry at the player. In clone entity, we'll set our angered variable to 0. Then we'll get an if else. If angered equals 0, then we'll put our point towards player and move in the else, and in the if we'll switch costume to green slime and replace walk with idle. The rest can stay the same. Now we'll have an if the distance to player is less than 120, then we will then set angered to 1. So if we're close enough to the player, we'll become angered. And then the else, if we're far enough away, so if greater than, and I'll change the 120 to a 180 so there's a bit of buffer room, then we'll set angered back to 0. So now we see the slime over in the bottom left is not angry at us. Let's go over close to it, and now it is. And then they go back to idle. And we know they're idle because they're playing their idle animation. And now they're walking toward us again. Great. It's a pretty simple first enemy. Alright, now I'm going to add one more type of entity, which is the spider. So I'll head into my sprite I got with costumes and drag out all the spider costumes into the entity sprite. I'm going to drag the first idle costume into tiles, and tile key map, I will add a 9. In entity, in our spawned entity, if type equals 35, set type to spider, width and height will both be 10, and move enemy. If type equals spider, then make a new block called take spider. Run without screen refresh. I'm going to duplicate our tick slime code because it will be similar to that. Alright, so our spider will just switch back and forth between walking around in a random direction and then staying still. We'll replace our green slime with spider. Our modulo will be by 4, not by 6. Now we'll replace the distance to player with pick random 1 to frame is greater than 10. So the longer we've been idle, the higher chance it is for us to become angered, or not really angered at the player in this case, because we can use the angered variable for whatever we want. So we're going to set angered to 1, and then we're going to set frame back to 0. And then we'll point in a random direction. So point towards random direction. Okay, in the else we'll remove the point towards player. We'll keep our move forward. I'll remove this random and just leave it as a 2. And then I'm going to move forward 1 plus angered times 2. So the angrier we are, the faster we move. Then replace this distance to player with another random 1 to frame. And if it's greater than 20, we'll set angered back to 0 and also set frame to 0 and point in a random direction. Now if after moving forward our speed x or speed y equals 0, so meaning we probably collided with something, then we're going to turn around into a random direction. Okay, so we're only using an angered of 0 or 1 right now. Once we code the sword in the next episode, we will change that. We will have it so when we damage the spider will become more angry and charge at us. Right now we're just having a random direction. So let's remove our slimes and place down some spiders. So now we can see they're walking. Now they're all walking at basically the same time. So I'm going to have a when I start as a clone, if type equals spider, then set frame to pick random 1 to 12, let's say. So now they walk at different times. Alright, let's try leaving the room and coming back. Aha! Our spiders are in this room also. And now they're in this room. And now they're here. We have not yet coded enemies into our saving and loading scripts. We'll modify our load room custom block. So we'll separate off the repeat loop down at the bottom. And now we'll loop through our entity lists and add those to our save code also. So set index to 1, repeat, length of entity index, then set room code to join room code, and then rather than tile and amount, we will say item index of entity index, and then item index of entity type. And then we'll put our underscores between them, and then of course change our index by 1 so we go to the next item in the list. Then finally, at our final set room code, we'll replace this underscore with a slash to indicate that that's the end of the tile part, and we're on to the entity part. Now in our load room, we not only delete all of grid, but also delete all of entity index and entity type. Rather than repeating until it's blank, with an or repeat until either it's blank or it's equal to slash. And if it's equal to slash, then that means we need to read the entities. So then we'll repeat until it's blank, and then we aren't using amounts of tiles. However, we can still use these same variables. Tile is the first of 2 bits of data, and then amount is the second. So we'll add tile to our entity index and amount to our entity type. So even though these variable names aren't super descriptive in this use, they still work the same. We also need to modify our reindex value to check not only for an underscore, but also for a slash. And then I'll do the same up here at the top. That way we don't get stuck in an infinite loop. In our letter index of room code, we need to make sure we say index -1 of room code equals slash, because when we read our value, the current letter will be placed 1 ahead of the previous like underscore or slash. So we need to read the previous letter. Now when we run it, our entities will be gone, but that makes sense because we haven't saved our room with them in. So let's place a few down. And now they're there. Let's enter the editor, and that works just fine. Let's go into the room to the right, and they are no longer there. When we go back, they are back. Okay, wonderful. Now, I know these aren't the most exciting things ever because you can't actually interact with them and they can't hurt you, but this episode has gone on for long enough, so that will be a topic for our next episode. Anyways, I hope you all have a great rest of your day, and goodbye. I'll see you next time.